Okay, this is chapter 7.3, proving that a quadrilateral is a parallelogram. So the essential question is, how can you prove that a quadrilateral is a parallelogram? What you will learn in this chapter section is how to identify and verify parallelograms and show that a quadrilateral is a parallelogram in the coordinate plane. So let's take. Okay, so before we get to any examples or exercises, we want to do a couple of theorems. Theorem 7.7 says a parallelogram opposite sides converse. Okay, so if both pairs of opposite sides of a quadrilateral are congruent, so right here they're showing that AB is congruent to CD, okay, right here, and BC is congruent to DA, then ABCD is a parallelogram, okay? So that's the converse to parallelogram opposite sides. Theorem 7.8 says a parallelogram opposite angles converse if both pairs of opposite angles of a quadrilateral are congruent. So angle A is congruent to angle C, and angle B is congruent to angle D, then that is also a parallelogram. Okay, so that's pretty much it. Opposite sides are congruent and opposite angles are congruent, then that four-sided figure is a parallelogram. Okay, so here we have an amusement park ride that has a moving platform attached to four swing arms. The platform swings back and forth higher and higher until it goes over the top and around in a circular motion. Okay, so what they're talking about here is, I've been on a ride like this. Let me draw a segment to show you what they're talking about. The platform that the riders are on is right here. Okay. Well, that platform originally was sitting like right here. So you get on the ride and it says this thing starts to swing like this. And it starts to go higher and higher and higher and higher. And then finally it goes, woo, it goes around just like that. Okay. And that's the ride. So it says here in the diagram below, AD and BC represent two of the swing arms. And DC is parallel to the ground. Okay, so AD and BC, which are both 16 feet long, are swing arms, and DC is parallel to the ground, line L. And they've marked it parallel here and here. Explain why the moving platform right here, this is always parallel to the ground. So what you're going to say is the shape of quadrilateral ABCD changes as moving platform swings around, but its side lengths do not change. The length of the platform is always the same. The length of the swing arms is always the same. Both pairs of opposite sides are congruent. They're both 16 feet. AD is congruent to BC. They equal 16. So ABCD is a parallelogram by the parallelogram opposite sides converse. Okay, the other swing arms, the platform you're on, and this are both 38 feet long. And this is 16, and this is 16. So by our converse theorem of opposite sides, the ABCD is a parallelogram. Okay, so by the definition of parallelogram, AB is parallel to DC. And because DC is parallel to line L, then AB is also parallel to line L by the transitive property. Okay, so if AB is parallel to DC and DC is parallel to L, then AB is parallel to line L. So the moving platform is parallel to the ground. And that says, explain why the moving platform AB is always parallel to the ground. And there it is. And so that's it. Just using transverse property and the converse to opposite sides are congruent. And using parallelograms, we can prove that the platform is always going to be parallel to the ground. Okay, so now you should be able to do problem numbers 3 and 4 in your exercises. Okay, example 2 says finding side lengths of a parallelogram. For what value of x and y is quadrilateral PQRS a parallelogram? So what we have to use here is, if this is a parallelogram and it says and we want to make the side lengths congruent. Okay, the opposite sides have to be congruent if this is a parallelogram by that theorem. So I want to say that side PQ, segment PQ is congruent to segment SR. Okay, the other thing we can say is segment PS is congruent to segment RQ. Okay, opposite sides are congruent. So from that, if we want this to be a parallelogram, these must be congruent, the opposite sides. So that's what we're going to try to do. We want to make this side equal to this side. So PQ is x plus 9. And that has to equal SR, which is 2x minus 1. Over on the other sides, we have PS, which is y. What did I just hit? PS is y, and that has to be equal to x plus 7. Okay, well here, that's a linear equation and there's infinite solutions. So I can't do this. If x is 1, y is 8. If x is 2, y is 9. If x is 3, y is 10. So I can't solve this for one particular amount. So I need to go over to an equation that has just one variable first. So here we have x plus 9 equals 2x minus 1. All there are x's, so we can solve this. So the first thing I always like to do, I know students often will move the constant first. I always like to move the variable first, and I move the smaller one so I don't get negatives. So x minus x is 0, leaving 9 on the left. 2x minus 1x is x, and then I have a minus 1. Add 1 to both sides, and we get 10 equals x. So there's one answer, x equals 10, and you always want to check that. So that means x is 10 here, and x is 10 here. Well, 10 plus 9 is 19, and 20 minus 1 is 19. So that checks. But now what we're going to do is we're going to take that 10 that is equal to x, and we're going to substitute it in over here. So in other words, this is 10. So this is 17. So y, let me do this. So y equals, substituting in 10 plus 7, y equals 17. So y is 17, and this is 17. Because 10 plus 7 is 17. So if x is 10 and y is 17, that would make this quadrilateral, PQRS, a parallelogram. So nice to be able to do problems numbers 9 and 10 in your exercises. Okay, 2 more theorems before we do any more examples. Theorem 7.9 is the opposite sides parallel and congruent theorem. So it says if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So in this diagram, they're showing us that side BC is the same length as AD, but they're also parallel. So BC is, if BC were 10, AD is 10, and if they are parallel, if their slopes are equal, we're leading up to in the coordinate plane here, if two sides are congruent and parallel, then quadrilateral ABCD is a parallelogram. Okay. And then theorem 7.10 is parallelogram diagonals converse. So it says if the diagonals of a quadrilateral, so if we were given ABCD as a quadrilateral and did not know it was a parallelogram, and we drew a segment BD and a segment AC, the two diagonals, and if BD and AC bisect each other, in other words, so if I put this E here, that means if BE is congruent to DE, it bisected BD, and AE and EC are congruent, which means AC was bisected, then ABCD is a parallelogram. So if the two pieces of each diagonal are congruent, then it's a parallelogram. Okay, so let's take a look at some examples about that. Example 3, identifying a parallelogram. So here we have a doorway shown in the part of a building in England. So the doorway shown is part of a building in England, okay? Over time, the building has leaned sideways. Explain how you know that SV equals TU. How do you know this side here is equal to this side here? Solution. In the photograph, ST is parallel to UV. Okay, so I'm going to mark this up. ST is right here. UV is right here. And there's a parallel marker right there. ST is congruent to UV. So now I have a pair of opposite sides, parallel and congruent. So by the opposite sides parallel and congruent theorem, quadrilateral STUV is a parallelogram. And by the parallelogram opposite sides theorem, since this is a parallelogram, the opposite sides have to be congruent. So once we know it's a parallelogram, we can say side SV is congruent to TU. Okay? And that's all you have to do to prove those two sides congruent. Prove it's a parallelogram, and then opposite sides have to be congruent. Now you should be able to do problem numbers 5 and 8 on your exercises. Okay, example 4 says finding diagonal lengths of a parallelogram. So it says for what value of x, so we have quadrilateral C, D, E, F with two diagonals drawn and they intersect at N, okay? It says for what values of x is this quadrilateral CDEF a parallelogram? So if we go back to slides here, what they're talking about is the parallelogram diagonals converse. So if these two diagonal pieces that meet in the middle, okay, two diagonals intersect, then each is bisected. So that's what they're talking about. So if CE and FD intersect at the midpoints of each side, then this is a parallelogram. So we want to prove, we want FN to equal DN. Okay, we want the two sides or the two segments to be congruent. Okay, so I could say segment FN is congruent to segment DN, or just FN equals DN. And FN, then so there's our formula. If this is a parallelogram, then those two pieces must be congruent, these two. Okay, so Fn equals Dn is my setup of my formula, and then I substitute the givens. Fn is 5x minus 8, and that has to equal 3x. Subtract 3x from both sides. Move the smaller x first. 5x minus 3x is 2x. I still have a minus 8. 3x minus 3x is 0. Add 8 to both sides, and I get 2x plus 0, or just 2x equals 0 plus 8, and divide both sides by 2, and I get x equals 4. So for what value of x is quadrilateral CDEF a parallelogram? Well, it's when x equals 4, because 5x minus 8 equals 3x. 5 times 4 minus 8 has to equal 3 times 4. 20 minus 8 equals 12. 20 minus 8 is 12. They are equal when x is 4. When they're equal, that's a parallelogram. So now you should be able to do problem numbers 13 and 14 in your exercises. Okay, so now we have a concept summary. So these are the ways you can prove that a quadrilateral is a parallelogram, all in one nice little table. So show that both pairs of opposite sides are parallel, and there's the diagram. 2, we can show that both pairs of opposite sides are congruent. Here's a diagram. 3, show that both pairs of opposite angles are congruent. Okay, that's another way. 4, show that one pair of opposite sides are congruent and parallel. And then finally, 5, show that the diagonals bisect each other. Okay, so there's the concept summary, all put together in one nice little table. There's 5 different ways to prove a quadrilateral is a parallelogram. Okay, example 5 is a quadrilateral in the coordinate plane. And so we want to identify it as a parallelogram in that coordinate plane. So it says, show that quadrilateral A, B, C, D is a parallelogram? Well, two ways we can do this. So from that table on the previous slide, I'm going to use 2 or 4. Those are the two ways to prove this. You can either prove opposite sides congruent or one pair of opposite sides parallel and congruent. Let's do both on this example so you see both in action. So number 2, show that both pairs of opposite sides are congruent. So I want to know the length of AB. So I'm going to write AB equals the square root of, and I'm going to, oops. Yeah, that's right. Plus, here, let me start over here. It is the square root of the difference of the x's plus the difference of the y's squared. Okay, so for AB, this is my end point, this is my other end point. Okay, so x2 minus x1, so 2 minus a negative 3 is plus 3, and then 5 minus 3 over on the other side. So AB equals the square root of 5 squared plus 2 squared. So AB has a length of 25 plus 4. So AB has a length of the square root of 29. So that's 5 point something. Leave it in radical form. It's just fine. So AB is the square root of 29. So now I want to find the length of CD. So now I'm going to say CD equals, and do my square root distance formula. Okay. And I'm now working with these two. So let me erase these. Okay. So x2, 5, minus x1, 0, plus y2, 2, minus y1, 0. So CD equals the square root of 5 squared plus 2 squared. So CD equals the square root of 25 plus 4. CD equals the square root of 29. So this is the square root of 29. So now I know this is congruent to that. Okay? So I'm going to continue doing this. And now I'm just going to switch colors here. And now I want to find AD. Okay? So AD equals the square root of y2 or x2, 0 minus a negative 3 is 0 plus 3, and 0 minus 3. So AD equals 3 squared plus 3 squared, because negative 3, 0 minus 3 is negative 3, and negative 3 squared is a positive 3, or I should say, I should actually write that. So let me put it. It's not 3 squared, it's minus 3 squared, negative 3 squared. 0 minus 3 is negative 3. All right, AD equals the square root of 3 squared plus negative 3 squared. So AD equals the square root of 18. So this is the square root of 18. And then finally, we're going to do BC. So BC equals the square root of, and I just do my formula and substitute in. So now we're doing BC. So let me erase all this. Okay, BC. X2, 5, X1, 2, 5, 2. Y2 is 2, Y1 is 5, 2, 5. So BC equals 5 minus 2, which is 3, squared, plus 2 minus 5 is negative 3, squared. So BC is going to equal 3 squared, which is 9, plus negative 3 squared, which is 9, and BC is going to equal the square root of 18. So I'm going to put the square root of 18 here. So now I see AD is congruent to BC, and AB is congruent to CD. So therefore, since opposite sides are congruent, this is a parallelogram. So that's one way to prove it. The other way to prove it is to show that one pair of opposite sides are congruent and parallel. Okay, so now I want to prove one of these pairs are congruent and parallel. So since I've already done both, it doesn't matter which I do. Let's do AB and CD. We know they're both square root, so I'm going to say AB equals CD because the square root of 29 equals the square root of 29. Okay, so I already know that those two sides are congruent, and that's a pair of opposite sides. So we already shown that they're congruent. We just need to show that they're parallel. You don't have to do both of these. I'm just showing you how to do one and then do the other. Okay, so now I want to prove AB is parallel to CD. So I want the slope of AB. Let's change colors now. I want the slope of AB. So M is slope, and I just put a little AB down here. The slope of AB equals, and it's y2, so this is AB, so it's AB. Y2 is 5 minus y1, 3, over x2, which is 2, minus x1, which is a negative 3. Be careful, minus negative 3 is plus 3. So 5 minus 3 is 2. 2 plus 3 is 5. So the slope of AB is 2/5. Okay, and then I'm going to do the slope of CD. So the slope of DC, let's call it DC. The slope of DC equals y2 minus y1 over x2 minus x1. So the slope of DC equals 2 minus 0 over 5 minus 0. Okay, so the slopes are equal, the sides are equal. So since the slopes are equal, these two are parallel. So I have AB is parallel and congruent to CD, and we wouldn't need to have found the lengths of the other sides. So either way you prefer to do it. Do you want to do the distance formula 4 times, or the distance formula twice and the slope formula twice? And remember that when you're doing it in a coordinate plane, you can find the slope really easy by going up to over 5. And there's your slope, rise to over 5. Up to over 5, rise to run 5. Okay, so now you should probably be able to do 17 and 18 in your exercises. Okay, so that brings us to the end of chapter 7.3. These are the exercise problems I asked you to do. I also threw in a few review questions because this is a short assignment. Thanks for watching and have a great day.